Wait a minute, this is 6A.
Yeah, it's because there's a lot of proofs. We basically take everything that we learn in algebra in this one last chapter, and we prove it all.
There's 2 proofs in the entire chapter.
Agreed.
So how is that?
You'll see why.
The proofs are the homework.
How about we cover last night's homework first?
Want it?
After we go over it,
By the way,
you're kind of needy today, Ben.
hey, I have a question for you. What were the numbers in the homework?
They're on the board right now.
1 through 16 or?
1 through 16.
I can't see
Okay.
the board. I don't know. Yeah.
There he goes.
You know, in Minecraft, you get free real estate.
I'm going to sometimes. Yeah. Almost like, they build a secret little bunker.
I gotta buy some paper towels.
Oh no, bunker base.
I don't like it.
Do it in a plane? That's gonna take a lot of help. I doubt you actually were able to make a double line piston trapdoor.
You have to
Is that?
You just have to have a little star.
All right, questions on the homework.
Yes,
It was long, but I-
Also, 'cause
Number 16. Let's take a look at number
yeah,
16.
16 is good.
Oh, making that triangle, I didn't know what to do. Just find the midpoint, that's what I thought.
I said it first.
What did you say first?
She said I'm copying her. She's been copying me? Oh.
You guys copied
Whoa.
Find the length of the longest median of the triangle with vertices. So
Oh, yeah, I did find
it gives us all 3 vertices. So what's step 1?
Draw a triangle.
You could, right? I mean, it would help you visualize what's going on. But I will say it says find the length of the longest median. Now this one is comp in the sense of what you do. Okay, so I'm just gonna draw a triangle. Let's just talk it through. So a triangle has 3 vertices. What's a median?
It goes from one of the vertices to the midpoint of
Yeah.
the
So
hypotenuse.
basically, I need to know the length of that. Well, we know how to find the midpoint. It gives us the vertices, and then we just use the midpoint formula to find that, and then just distance formula. And you have to do that how many times?
3.
That's how it's done.
And
No, I'm not going to do it, but
longest?
it's a little bit of drudgery there, but that's all you had to do. So do the midpoint formula first, find the midpoint, then take the vertice and that midpoint, use the distance formula, and then whichever one's longest is the winner. And the book says the answer is the one that comes from y. It says it's the square root of 89.
Oh.
All right, anything else?
I don't like transformations.
Yeah.
We will only get, like I said, I'll probably just do the dilation class. If in fact we even have time for it, who knows, snow or something to rear its ugly head. All right, here we go. Even ones. Now let's see, there's 2 answers because the first one is the coordinates of the midpoint. Oh, it's 2 of them.
What?
Well, x and y.
Yeah.
All right. So number 2 is 1, 9/2 or what? 4.5. Number 4 is a plus 1, 2. Number 6 is a plus c over 2 and b plus d over 2. Number 8, length, slope, midpoint. Length, slope, midpoint. Length, slope, midpoint. All right. Number 8, the length is 2 root 29. The slope is 2/5, and the midpoint is 2, 6. Number 10, find the coordinates of B, so the end point. So they give you the midpoint. Well, how do you do that? How'd you guys do that?
Number which one?
10 and 12.
I don't know the actual math that I did. I just kind of thought of that.
Well, one sec. Let me explain it.
So they give you a point, and they say that here is the midpoint, and they're asking you to find where's the other point. How did you do it?
I just did like what
Well,
plus that divided by 2 equals.
yeah, it was like
You could do it that way.
they
That's
were
one way.
both on 4, the x. So if it was
Yeah, number 2 is easy because they're both on 4,
So you just do 6 plus 4.
That's the other way of doing it. Remember, we had that other one where if the slope is up 3/1, you could just go up 3/1 to find.
Yeah,
out.
that's what I did pretty much was.
But you would have to calculate the slope.
What I would
Did you do it that way or a different way?
It is different. 10 was easy
What did you do?
because both of them were on 4 on the x-axis.
Oh, so it's a
so it's a
vertical line.
vertical. No, it's a.
You said the x's are the same.
Right, so it is a vertical.
Vertical line, so you could just count. Okay, that'll work. Yeah.
What I did is I took the x. I'm doing the same thing just for y. I'm just using the x coordinate as an example. You take the midpoint x, multiply it by 2, and then you subtract x, y.
Yeah, that's what they were saying.
And
Just
that's-
use the midpoint formula and solve for it. Yes. Yeah. Okay.
So
Now, obviously, so 10 is 4, 10, and 12 is, well, they just give you a bunch of variables, so it's just plugging some things in, using whatever that technique was. Now, be careful; it depends upon your technique. The book is claiming 12 is -r, 4 minus s. 14, show that RST is isosceles. So you need to show that 2 of the sides are the same. It turns out that wasn't this the one you asked yesterday? Well, which one is the isosceles?
not the
and-
isosceles. Which one was the? Yeah.
Which one of the two congruent sides, right?
No, it was for B.
Oh, okay, I got you. Well, the two congruent sides are RS and ST, and they're both 2√13. Well, the only way you can do that is you got to do all 3 sides to figure it out. I guess if you put them on a graph, you
I
can
got
kind of
lucky.
visual eyeball it.
I got lucky. I picked the right.
You pick the you're right. What's the percentage of, what's the probability of doing that?
one
What's
out of-
probability?
It's 16, 17%.
What's probability?
17%.
How many ways to win the game over how many things that could happen?
Right.
So
1 over 6.
There's 1/3, which is 1/2, which is a 33, not
because-
But there's
17.
multiple.
right, but remember, all we got to do is we got to choose 2 out of
Bit
the
weird,
3.
okay.
Any 2 out of the 3 is either a winner. If you choose 2 out of 3, I mean, or it's a permutation thing or a combination thing. So how many combinations are there if you have 3 things?
3.
But you got to choose 2 of them.
So it's 6.
So there.
So the first time you choose one, there's 3 possible choices. Now there's 1 left,
Now
or
there's
2
two
left, sorry.
possible
And then there's 2,
choices.
so there's 6 total combinations. So there's 6 ways of choosing 2 things out of 3, right?
Yeah, but there's 2, so that means
So
2
there
over
are
6.
6 ways of making your total
And
choices.
there's 2 because you can go like if we had if the lines were labeled A,
And
B,
As
C,
you choose them, how many winners are there?
there's 2.
So we already knew the answer was 1/3. I'm not where he was getting 17%, but so it's
I thought it
1/3.
was 1/6.
Okay. Well, there's something that we haven't done, and we do geometric. Did we already have a class? Yeah, we had a class on geometric probability. Yeah, we did. Okay. Well, that wasn't the answer to either A or B. I gave you A. B is 6, -1. And then we already talked about 16, which was the median from Y. I don't think they find. No, it says find the link. So square root of 89. Square root of 89. So what's the combinations? You want to visualize it.
No, I know what it is.
So-
You don't have to explain it to me.
Winner, winner. The first one's a winner, the second one's a loser. First one's a loser, second one's a winner. Where are the 6 possibilities?
I did a permutation instead of a combination.
Is there any way of making more choices?
No.
There's
Unless you add more.
3
stuff.
choices, 1 winner. Like, we choose.
No,
2 out of 3.
I didn't visualize it. I just did a permutation. And
Wait,
then
but-
Well, remember, permutation is when order
I
matters,
know.
right?
So
And
then,
it doesn't matter whether the first one's a winner or the second one's a winner, it's the same thing. All right. Somewhere I have a piece of paper. It must be right here.
You want my homework?
As always, I'll collect it for you.
Okay.
One for you, one for you, one for you. Now, it will take us 2 days to get through this. It's probably not exactly 2 days, but it's at least a class and a half. So I can't do it all in one day. Quiz tomorrow. So what's the quiz going to be on? The quiz is going to be on,
4, 5, and 6.
what do we do on 13.4?
We did the vertical.
Close.
Slope.
Something like that.
Vectors.
No, that was.
It was vectors.
It was
Oh no, it was vectors
vectors,
Midpoint,
intercepts,
in
whatever
today's
it is.
class. I'm also going to throw parallel and perpendicular lines.
Why do we have 2 chapter reviews on 13?
I was a bit worried about the other class
Well, you don't need to worry about us.
in field day.
Field day is on Wednesday
Field days on
What? They
Wednesday.
changed it already?
because it's supposed to rain or snow on
Oh,
Monday.
then yeah.
So it's the same thing. It's just moved to Wednesday.
Yeah.
Okay.
Then,
And
yeah,
if
we
it gets
definitely
canceled
need
for
to-
Wednesday, then it gets moved to Thursday. And if
Then
they can't do it Thursday, then it's canceled.
Miss Allen is like serious planner.
She gets 3 opportunities. She
All
said.
right. Well, obviously, this is not going to change in any substantial manner other than just moving things around. So we'll do 13.8 on Monday. But then it's better that we are doing it because then it will be literally broken up, right? Between field day if we do it on Wednesday. Okay, cool.
And then the test, and then we're having another test a week later. So
Got that right.
fun.
You remember how that worked at Christmas time?
No.
So you have 7 classes, 8 county thing, but 7 classes. So every day there's 2 classes that potentially have semester final. It just depends whether your teacher gives you a semester final.
Except for one.
All your core classes are going to give you a semester final, but your elective teachers, it's entirely up to them. So you can count on 100% you got a semester final in history. You guys have 2 English classes, so it's 5 for you guys. You guarantee you're going to have 5 semester finals, but your other ones you're going to have to talk to your elective teachers.
Latin and
I don't
Is
remember
Latin gonna do it?
having one
Yeah.
last year.
So you got 6 semester finals.
I'm not.
Miss Boyd said our concert would just count as our.
There you go. And it'll just be like, hey, I forget what we did, period 1 and 3, 2 and 4, 5, something like that. Miss McCullis makes that, so she'll be coming out with that pretty quickly. All right, homework.
Aha, I knew it was gonna be short today. Wait, except for lessons.
I did something.
So somehow I didn't like question 5 or 6.
Yeah, I can see why.
Why didn't I like 5 and 6?
On the same axis, graph the line.
just
y equals
pulling more
0.
stops.
Y
Oh, good
equals
Lord,
3.
that's a dumb question. They just want you to graph 3 vertical lines and another one 3 horizontal lines.
It was amazing though. We got to prove our smarts.
Already did it.
Cybertron.
Good for you.
I am not done. 11, 12, 13, or 14. Or 19, or 20. 22, 23, 24.
There's a lot of ones you haven't done.
I've done more than that.
All right, here we go. I already gave you the wind up on this one, which was basically we're going to take most of the stuff that that I told you since I was your algebra teacher, that I told you was true in algebra 1, and we're going to prove it. Which seems kind of backwards, but it is what it is.
Didn't we have done this at the beginning of the year?
Well,
No.
you didn't know what a proof was at the beginning of the year. And we are going to use some other stuff that we use throughout the year to do these 2 proofs. All right. Linear equations in a day, like everything you learned in algebra 1, that's just too much, but we're going to do it 2 days. All right. Remember, now this is a geometry thing. We defined a line as the collection of the points that extend in opposite direction. That was chapter 1, right? And then further in chapter 1, way back chapter 1, 7 months ago, we said how many points to define a line? Which some of you missed on that chapter 1 test, believe it or not, way back when, right?
What?
How many points to define a line?
I
And
did not.
2.
2 points. Okay, cool.
Some of us
So
did.
2 points to define a line. Now, remember, there's an infinite number of points because the definition is collection of points that go in opposite direction. But we only need 2 points to quote, quote, define a line. By define a line, that means giving it a name and figuring out what direction it goes into. And any 2 points work. Any 2 unique points. All right. We're going to move on to everything we did in algebra 1 when we said, hey, graph a linear equation. So graph a linear equation. So even though I'm going to show this without proof, it's really a definition. I don't like the fact that they made this a theorem. This is a definition. And it's basically, we didn't spend hardly any time on this last year at all. And it's, we spent time on quadratic standard form, but we didn't spend any time on linear standard form. So in math, standard form is, well, it's a name given to a function or to an equation that we all agree upon is the way that we're going to write it. So it's literally just called standard form. And for a linear, the form is, I should make this really large. I don't know why I made it so small. There's the form. Remember, all linear equations are the form. It's got an x, it's got a y, and it's got a constant. They chose to just rearrange those two variables, x and y, and the constant, into this form. Now, I could have written ax plus by plus c equals 0 as well, too. But we chose this to be the standard form. And you will see why here in a second. Why did I make that so small?
So using standard form, you could have 2 points, and you could put them in parentheses to have a line.
I think you're right about that.
Using the x-intercept and the y-intercept.
Can we just?
Well, that's what this turns into.
Right.
Okay.
So you could actually have like one.
A and B can be 0, but they both can't be 0. Why can't they both be 0?
Because then it is.
Because then it's just equals c, and it's just
And
not
0
a line.
can't equal C unless C is equal to
And then it
0.
would just be a point.
And it would just be nothing. It'd be a
Yeah.
number, right? And half the time, or more than half the time, it's false because 0 wouldn't equal C anyway, unless C was in fact 0. So we could say A is 0 or B is 0, but C can always be 0. But A and B both can't be 0. And I mean, notice this is called theorem. I didn't prove anything. I just said, hey, here's the definition. And the book is okay. It doesn't even give you any explanation of why this is a theorem and not a
You should have done postulate.
definition or postulate, right? We state a theorem for the standard form, but we omit the proof. Well, yeah, because of definition. Is it telling you answers, McKinley?
No.
Okay. If it was a cat, you'd be scratched by now.
Many times.
Are we good? Okay.
No.
So last year, here's the sum total knowledge of what we did with linear equations. Last year, I gave you an equation, right? I gave you linears. I gave you quadratics. A rare occasion, you might see a cubic. We talked about it. Names, definitions. This is a cubic trinomial. We talked about that, but we really only spent most of our time just graphing linear equations. Okay. So linear equations, remember they're named linear because the x is to the first power. This is called quadratic because it's to the x to the second power, and it's called a cubic because it's to the third power. Okay. In the last 3 years, you've graphed both in pre-algebra and algebra 1, and now in geometry. You graph linear equations, right? And we had 2 ways of doing it. We had the table of values. I call it the table of pain. Do you remember doing those at all?
Yes.
Okay. The second way, which was what you were introduced last year, was slope-intercept form. And you're like, whoa, this is really easy.
And then we get point slope form.
I briefly talked about it. It's actually not done in our Algebra 1 book, and I throw it in there always because it's like most Algebra 1's books do talk about point slope. We will talk about point slope in geometry as well too. But those were the 2 ways that we graphed linear equations. By the way, the table of values proved itself, but we never proved. We just simply said, hey, guess what? This number is the slope. This number is the y-intercept. Trust me, right? We never proved that to you. That's what we do today. Today, I will prove the slope-intercept form so we can use it. And then this year, meaning today, I'm going to introduce you to another way of graphing linear equations. Okay. All right. So it's called graphing the intercepts. Intercepts is used often. Like you get to pre-calculus, it's like the primary way that we graph things. Hey, graph the intercepts. Okay. So here's the idea. All lines, whether they're vertical, horizontal, or diagonal, always, they must cross at least how many axes?
One.
They must cross at least one. In most lines,
Cross two.
they do. I mean, most lines will cross both the x-axis and the y-axis. Most lines cross the x-axis and the y-axis. The only ones that don't cross both the x-axis and the y-axis are the last two there. But they do cross at least one. Okay? So let's explore that. All right, we are going to call where the line crosses both the x and the y, we're going to call those the intercepts. Now, you've heard of the y-intercept. We used it plenty of times. We never messed with the x-intercept, but it exists, right? Hey, how many points is this?
2.
How many points to find a line?
2.
So if we graph the two intercepts, if it's a linear equation, not a curve can cross many times, but if we graph those two intercepts, it makes the line. So the technique I'm about to show you is how to graph any linear equation simply by using its intercepts. Okay? So both the y-intercept, let's see, the y-intercept has what coordinates? Always. 0 for what? The x or the y? Okay, and it turns out it's opposite of what you would think. So for the y-intercept, the x value will always be 0. No matter where it crosses, up here, down here, the x value will always be 0. Okay, and then for the x-intercept, right. So in general terms, we say that the y-intercept is 0, something, and for the x-intercept, then it's going to be something, 0. Right? A and B. Why do they choose A and B? I don't know. Those are the variables they wanted to use. Nothing special about them. Cool. So let's write that down, please. All y-intercepts will be of the form 0. We're talking about the actual point. Will be of the form 0, B, and all x-intercepts will be of the form A, 0. Number one thing, this is a test question, and it's a simple one, and it should be simple. And then you stop thinking, and you just kind of wing it, and you're like, whoa, y's go up and down, so therefore it must be the y that's the 0. It's not. It's the opposite. For the y-intercept, it's the x that's 0. For the x-intercept, it's the y that's 0. Okay. All right. So what we're going to do is we're going to graph lines using their intercept. We're going to plot both intercepts. That's what makes a line. And it works great. I mean, it always works well when the equation looks like this. By the way, this is from the previous box. This is standard form. So if it looks like it's in standard form, use the intercept. If it's a linear equation, use the intercepts to graph it. It's really simple. You'll see here in a second. If it doesn't look like this, if it looks like y equals mx plus b, well, then use slope-intercept form. Further, next class, or 2 classes from now, we learn point slope. It looks like point slope, use that form. But when it looks like this, don't do any algebra. I want to put it in, I want to graph it on my calculator. You can use your intercepts to graph that really easy. And this is the reason, is that when it's in standard form, watch what happens. Look, standard form. In standard form, we know the y-intercept is what? -3. No, the y-intercept is in what form from the previous that you just wrote down?
0,
So we let x be 0. We just solve for b. Why does that make our life easy? Because it just gets rid of that. It's a one-step equation. So therefore, y is equal to, and then the x-intercept, we let y be 0. When you solve that one-step equation, and it says x is equal to, and you're done. And there's 2 points right there. One where the x-intercept is, and one where the y-intercept is. All right. So if you need steps, Well, step number one, and it doesn't matter the order you do this, let x equal 0 and solve. It's going to be a one-step equation. Really simple to do. All right, we get y is equal to -4. That's the y-intercept. So you put a dot on -4. And you repeat that process, you let y be 0. So therefore x equals 6. We put a dot on x equals 6, connect the dots, and you're done. And that's literally how quickly this, I would argue this is almost as easy as y equals mx plus b. It's a little bit more mathematically detailed because you got to actually do some math. Remember, y equals mx plus b, you graph the y-intercept, and then you just apply the slope. But it's pretty simple. Once again, when am I going to use this? I'm going to use this when they give me the linear equation in standard form. If you're doing this on the computer, on Desmos, you can type this in, 2x minus 3y equals 12, life is good. But on your graphing calculator, you can't type that in. It won't take it. You have to solve for y first. To graph, that's ridiculous. Why am I going to go through that hassle when I can just literally just plot the intercepts and be done?
No, I know how you're going to solve slope-intercept form. You're going to prove.
Thanks for ringing the phone.
I didn't tell you, did I?
No,
You want me to?
no, I already know it
If you want me
too,
to.
but
I was doing my homework. I was not looking at the proof. I promise you.
Okay, I'll be interested to hear what you say. Okay, let's do one. Box 2.
They both equal 3.
They both equal what?
3.
They both equal what?
0.
They both equal what?
They both equal 0, 3. And
They both
3,
equal
0.
what?
A number.
I'm trying to give you a chance to get it right.
I am getting it right.
they both equal a point on the graph.
Yeah.
They both equal,
2y equals 8.
look at it.
They both equal 4.
You had the right idea, I'm not sure where you're getting the 3 from. So yeah, they both equal.
Subtract it first, 'cause look.
No, we don't. We don't do any adding, subtracting. In fact, this is all going to be just multiplying and dividing. That's the power of the intercept, is because it's a less chance of making a mistake with adding, subtracting. So all we do is we let x equals 0 solve for y, we get 4. So that's the y-intercept. We put a dot on +4. You can mess this up, not this one because they're both the same number, but you can solve for it and put your dot on the wrong spot. We do the same thing for the x. We let y is equal to 0. We get x equals 4, put a dot on x equals 4, play connect the dots, you're done. All right, intercepts are really nifty and really handy. All right, quickly done. All right, redeem yourself, McKinley. Tell me what to do.
Okay.
Well, first you have to bring.
Let McKinley talk.
1 divided by -9, you get negative 9.
Okay, and what does the equation say?
0.
Yeah, no, read what the equation would say if you solved it, because we just got to figure out whether we're solving for x or y.
Well, then I'm solving for y.
Okay, so you would say
x is equal to 0.
all of that. What's the final thing? You're already at the end, by the way.
-9.
But what is -9?
The y.
Okay, so that's why I wanted you to say y is equal to -9. Why am I going to make you say that, pun intended? Because you got to think about it, McKinley. So you got y is equal. So we're looking for y -9. Okay, keep talking.
Be 3 divided by -9.
Other way around.
-9 divided by 3 would be negative. I think 3.
Yeah, but what's the equation say?
X equals negative.
So the x, we got to put it, x equals -3. There's your 2 dots. Like connect the dots, and you're done. Very good. Okay. I'm not joking about making a big deal about it, because you will put the dots in the wrong spots if you don't tell yourself that it's x equals or y equals. All right, we got intercepts. Right now, literally on the weekends, I'm planning for the pre-calculus class for next year, and I mean it's like every single problem. Graph the intercepts, graph the intercepts, graph the intercepts. And so understanding what it means by finding the intercepts is important. All right, I'm assuming that's a yay. So we just did that one. I'm gonna now prove it, or Jack is gonna prove it. Okay. So what do we got to prove? That a line of this form, y equals mx plus b, means that m is the slope and b is the y-intercept. So we got to prove 2 things. we got to prove that m in this equation is literally the slope, and we got to prove that b is the y-intercept.
So
That's our start, and that whoops.
x has a given value of 0.
What do you mean x has a given value of 0?
Well, if you're gonna graph the why don't you just prove it by proof of conjugate? Okay, well, you could do that. If you were to say that it was, so if you go to back and you were to subtract mx, you would get y minus mx, or negative mx plus y equals b, which is standard form.
mx. Okay, keep talking.
So then you can say that if you were to supposedly to graph the y-intercept, it would be, and x would equal 0. So you would say
So
that
if we were to graph the what?
if you were to find the y-intercept,
How do we do that?
you would put x as 0.
So if we let x be 0, we're trying to find the y-intercept
You would
from the
get
previous definition.
the
And that would go to 0, and it literally says,
y-intercept equals b.
all right, you're halfway there. He just did it, by the way.
I don't know how to figure out m though.
That's the hard one. Okay, so let me catch up with you. Very good. I'm proud of you. All right. So that's how he gets that. You go by the definition of what the y-intercept is. That's letting x equal 0. You didn't have to move it over there, but that was perfectly fine.
Ooh, what if you were to say that b divided by m equals the x-intercept?
What?
It would be negative. B divided by negative m would equal the x-intercept. But
What?
yeah, because if you were to do the exact same thing, then
Oh, I see. You're saying let y be 0 and solve. All right. I don't know. Let's see if that gets us anywhere. So you get 0 equals mx plus b, and then you want to move. Yeah, but we're trying to find out what m is.
Right. So if you're to move that to the side and divide.
And by the way, we got to prove that m is the slope.
Right.
How does that prove that m is the slope? Okay, so
Well, if you were to say that
that's kind of a dead end.
you could find out the y-intercept and the x-intercept and say that since those two divided equals m.
Okay, flesh that out.
So if you were to
Say it
find-
again slowly and think about what you're
So
saying.
the y-intercept equals b. We know that. So if we were to find out the
So he's
y-intercept,
saying, what do we need to find slope?
the x and the y.
What do we need to find slope?
The x
More
and the-
generally,
2 points.
we need 2 points. And he's saying,
Get the x-intercept and the y.
get the 2 intercepts, and then plug those into the slope formula.
Right, and then when it simples down, it'll equal it.
We hope it better, right? So how do we do that?
So you could say b is y-intercept, and then the x-intercept.
Okay, so
is
let's say it more than just b. What would it be? B is the what intercept?
x-intercept, y-intercept.
Well, that would be a point.
So you'd say b minus 0.
I don't know. We need the point.
So you need 0, comma y.
0.
Think it through. You're almost there, by the way.
0, comma
It's the y-intercept, so
0, comma b.
0 comma b, right? So there's 1 point. There's your y-intercept.
And then your x-intercept is m negative b over m.
Okay, so let's go back to our original thought there, which was, how do we find the x-intercept?
You make y equals 0 and solve for x.
Okay. So we got to solve for x.
So we subtract that, and then we get negative mx. And then we divide by
Now let's just
negative
move the
m.
b to the side.
Okay, so you get the same thing. So negative b over m. You're getting the same thing. It's just-
Right. So negative b over m is equal to x. So our
So
x-intercept,
you get negative b over m. Oh yeah, you get negative b over m, comma 0.
negative b over m, comma 0. Okay. Why did I do that?
So now you can plug that into the slope formula.
Okay, so that right there.
And you can say 0 minus negative b over m.
Okay, so we need to do what? Slope formula is y2 minus y1.
Oh, it is gonna work.
Okay, so which one is 1 and 2, or does it make a difference?
So it's 2 minus 1. It's y2 minus 1 over.
So which one you want?
So it's negative b over m. 0
Which-
minus negative b over m. So
What do you
can
want? Point 1, point 2.
Point 2 is on the bottom.
Okay, so this is 2, this is 1. All right, now do the math.
That would be negative b over n minus 0.
Changing y's first.
0
Oh.
minus b.
0 minus b over,
Negative
Negative b over n.
we got a big honking mess here, minus 0, but we get that. So does that,
Yeah, it does because you
and by the way, this is supposed to equal,
you do copy dot flip and then you get that the
M.
b's cancel out.
what?
Yeah,
So we
you
do copy dot flip and we get m is equal to m. Okay, I'll buy it.
Right, so slope equals n.
Did you follow that?
Yes.
I didn't do it that way, but I did it pretty close to that way. I mean, the logic is the same. I just didn't do it algebraically like that. Okay, so 2 points to find the line. We're going to let the first point, which is 0b, equal x1, y1. Okay, which is kind of what we did. Then instead of like pulling up the x-intercept, which clearly it did work, I can throw any value. Remember table of pain? I can throw any value in to get the second value. I'm just going to throw in, I'm going to let x equal 1. So if I let x equal 1, right, I get y is equal to m plus b. So this says y equals,
N plus y.
right? So my point there is when x equals 1, the y equals m plus b. So there's my second point. So here's my first point. Here's my second point. It's the same basic idea.
Oh, I see.
You just get 2 points. The algebra, I don't know, I didn't come up with this, but the algebra is a lot nicer and prettier, but it still worked the same way. Okay? That's just basic substitution. So there's my second one. Point 1, point 2. Circle. And then we just apply the slope formula. And it's really small, but hopefully you can see. So this minus this,
So it's n over
the b's
1.
cancel, it's m over 1, so m equals 0. There we go. And there was nothing wrong with the way you did it. Cool. You can have your book back. QED. And I wasn't lying to you last year. You can't use the formula. Okay, so that's 13.7. So if you have an equation that's linear x to the first power that looks like this, then we call that slope-intercept form, where m is defined as the slope and b is defined as the y-intercept. And this is the one that we used so many times last year in Algebra 1. And this is why this is a 2-day class, because this is as far, I thought this is literally exactly how far I thought. I didn't get to this chapter last year because of our late start. And so when I was planning it this summer, I was like, oh, I'm not going to be able to get through this whole thing.
See how easy that was? We don't need 2 days to work on it.
No, I'm saying I still got half of the material left. Look at questions 25 through 30. This is tomorrow's homework.
Oh, yeah. Okay,
I never even got to that.
I mean, I feel like I can figure it out.
Well, I hope so,
25
because
through 30, just those 6. All righty then.
I don't know if it's just those 6, but it will be
On
at
the
least
board.
those 6.
Then you could look on the board if you really want to do it.
Oh, yeah, I mean, yeah, that's not that.
No, I don't put anything in. Before.
No, over there.
Yeah, but oh, you're right. I do that, don't I? I forgot that I used to do it a day at a time. So literally every day I'd print out. When I only taught 2 classes, it was like, oh, I'll just print one out every day. But then when I had 4 classes, I was like, well, I'm not printing 8 or 4 pieces of paper every single day. Okay, so McKinley, what's the slope? This is what's on the quiz tomorrow too. What's the slope?
Pointed in there, but I didn't find the calculator.
You're looking at the equation, you're finding m.
Okay, so you just subtract.
You're literally looking at the equation and you're finding where m is.
-2.
Okay, what's the y-intercept?
4.
That's all I'm asking.
I got the
You want a harder question?
first
What is the slope of the line perpendicular to that one?
positive 2.
Oh my word.
Positive.
Well done.
Plus minus 4.
No, you had it right the first time.
1/2.
So 1/2.
Yeah.
Okay. What's the slope of the line parallel to that one?
Or
-2.
-2.
Okay. You got that, everybody? That's going to be on the quiz tomorrow. I will give you this and ask you what's the slope of the line parallel or perpendicular to that one?
You just do like this.
Opposite reciprocals. Okay, slope -2, y-intercept 4. Uh-oh, now we got a problem.
I don't like problems.
So Ben, how are we going to solve this one?
Well, first you gotta figure out.
First, you're going to look up and look at it.
So first, you gotta figure out the numerical values to the question pointed at. So we got the slope and the y-intersection. Well, we don't. Well, here's the thing. Even though we don't have the x-intersection, so we can't the y and the x.
Don't make this
on
more
the line,
complicated than it needs to be.
We have the slope, and we can calculate the next possible.
Where's the slope?
Right there.
No.
Oh well, first we gotta reduce it. I reduced into a simplistic form.
What do you mean by that?
We gotta stop doing it with your head. We gotta
Just leaning back.
yeah. We gotta first make sure it equals y equals. We gotta make
Hanging
sure
it
it
on the
equals
table.
y.
then?
You're almost there, Ben, but not yet.
Yes, I am. Well,
You have to make sure what?
we gotta make sure y is on the left and below.
Hey, what form is this called?
System of equations.
No, that's tomorrow's night.
Technically,
System of equations. would be
This is in standard form.
system of an equation.
System means more than one. This doesn't tell us anything. Could we find the intercept from this? Sure can, but we can't tell slope or y-intercept without doing work. So we have to do some work on that. So how are we going to determine the slope? By the way, it does say y-intercept. We can find that out just by
Yeah.
throwing in a 0 for what? X or y? Okay. So therefore, the y-intercept is, this is the same one as,
Or
no.
-4.
So how do we find the slope?
Well, first we gotta make sure y is in the far. We gotta put it to m. We gotta put the.
Finally.
MX plus
Why did
b,
that take 5 minutes for you to say?
Because I didn't want to say.
Okay,
it.
so what am I going to do?
Divide everything by 3.
Could you do that first?
Divided by 3. Yeah, divided by
All right,
-3.
fine. I'm going to subtract 2.
No, I'm asking you, could you divide by 3
Yes.
first?
Don't divide by 3. Divide by -3.
I probably would divide by -3 first.
Okay.
But I don't have to, right? I could divide by 3. It leaves me with a
Negative
negative y, but
First, let's move the 2x over
Okay.
to the right. So just subtract 2x from both sides.
okay.
Now we should divide everything by -3, giving us y equals 2/3x minus 4.
So what was the answer though?
Well, we know that, the slope is 2/3.
There you go. Okay, and we already did the y-intercept. By the way, if you do the slope first, there's your y-intercept, right? You didn't have to throw 0 in from the very start. You could. Jack, what's the problem?
I'm just thinking if you divide it by -3, then you would get y equals a -2x minus 4.
If we divide everything by -3 at the start, we would get -2/3 plus y is equal to -4. Then you would x. Sorry. Then we add 2/3 to both sides. And you could do that, right? Most people do move the addition and subtraction first before they do division. All right. On your own. I think this is the last thing, right?
We have 3 more boxes.
3 more boxes?
We have to graph them.
Oh yeah, that's the easy part.
You just type them into your calculator.
No,
Exactly.
on paper.
Yeah.
You can
I mean,
type it
it's
into
easy
your
to do on
calculator,
paper.
correspond it with the real thing.
And you say calculator, print.
Well, no,
Oh,
yeah,
thanks.
it's not that hard to
You can be like
correspond
Tony
it. You
Stark
just
and be
have
like,
to-
print.
They do have calculators that print. You can't use them on the SAT though.
But I already did some graphing on there and I can.
Good job. Now you can
corres-
check your work when you do it by hand.
But I can correspond it.
You can check your work.
Oh.
All right. Allie, slope, y-intercept, the first one.
The slope is -1/3.
Of the first one?
Oh, wait. Oh, I was looking at 6. Oops. The slope is 5 and the y-intercept is -.
So there's nothing to do there. Anna, last one.
Slope is 2 and the y-intercept is 5.
Yep. I had to do that math myself. Okay, we're not doing that. So we'll move on to the last thing because I have 2 minutes left. All right, who forgot how to do this?
Not me.
Mikhail, you remember how to do this?
I think so.
Tell me what to do.
Y-intercept, you go from 1
Where?
on the y-axis.
Okay, so put a dot on the y-intercept, which is 1.
Alright, and do why you
It's my animation's out of sequence, so ignore that dot.
then just rise over 1, so I guess 1 over 2.
Look at the slope again.
Slope is 1.
Look at the slope again.
No, 2. Sorry,
2 over,
so 2 over 1.
yeah, so up 2 over 1. That's why this dot's right here. So from 1, from that dot right there, up 2 over 1. You want to go in the other direction? What do you do?
Go down, no, negative 2 over
You write the opposite of the slope. So negative 2 over 1. So down to left 1. Down to left 1. Okay? So opposite slopes. Okay, cool. Do you have to do 3 points?
No,
You know.
but it's right.
Do we need to do more of these or you remember doing this?
I remember doing this.
Okay. You sure? All right. Did I do the animation on order here? Yes, I did. Why is my animation out of order? So the correct way to do it is the y-intercept first, which is at negative 2, right? Not there. Or yeah, right there. And then the slope is up 2 over 3. Go in the opposite direction, down to left 3. Boom. And no, we won't do that last one. All my animations out of order on this one. I know why, because I didn't teach this last year. Like, I would have caught that left. What's
Bound to
left?
be math mistakes.
It's not math mistakes, it's just the animations out of order.
So there's
The
bound to be
line
math
is
mistakes
correct.
too.
Not in today's class.
Sure.
Pretty sure you would have caught it if there was one.
Oh, I was thinking.
What's left to do? We got 2 things left to do. We haven't talked about 2 types of lines,
Vertical and horizontal.
vertical or horizontal, and we didn't do system of equations, so that's tomorrow. All right, and that will finish it up for this particular one. Yes, I'm glad I made that decision. Oh, and I got 1 minute to go. What do you know? Actually, I have no minutes to go.
No.
Yeah, they are.
No.
You want our homework?
I want your homework.
Are you sure you want the homework?
I am sure.